Hey guys, Miss Tate here. So we have a new TEK today. So this is our TEK 4.5b. It says represent problems using an input-output table and numerical expressions to generate a number pattern that follows a given rule representing the relationship of the values in the resulting sequence and their position in sequence. That's a whole lot of information, but we are mainly going to focus on this input-output table section, and we're going to be focusing on figuring out what rules these different tables follow so we can generate some patterns here. So let's take a look. Let me show you what an input-output table looks like, and I'll show you what we're going to do with this. So this is an example of an input-output table. Now, every single input-output table has a pattern. It's kind of like a puzzle. We have to figure out what pattern this input-output table is following and what rule it's following. So I'm going to help us kind of use our imaginations to figure it out. So an input-output table always starts numbers with on the input side, and then we get numbers on the output side. So I want you to kind of imagine this imaginary number machine. That's what this little thing is called right here. So it's a number machine, and we're going to put numbers into this machine. Input, get it? We're going to put numbers into this machine, and we're going to get different numbers out of this machine. So if I put in a number 1 into this number machine, out's going to pop a number 2, like this. So I put in a 1, this number machine is going to do something to that 1, and it's going to turn it into a 2. Out pops a 2. Our job is to figure out what is the number machine doing to those numbers to change them. All right? How about I put in a 2 into the number machine, out pops a 4. Think about what is it doing to make that happen. Keep going. You put in a 3 into the number machine, out pops a 6. Put in a 3, out pops a 6. And lastly, I put in a 4, out pops an 8. What did the number machine do? Now here's the thing. The number machine has to do the same thing for every pair of numbers, right? The number machine won't do something different up here than it is down here. So can we figure out what this number machine is doing? So how did it get from 1 to 2? What are some options on how it could get from 1 to 2? Well, there's only 2 things it could do, right? Because the numbers are getting larger. So it's either adding something or it's multiplying by something. Let's try adding. 1 plus what gives you 2? Well, 1 plus 1 gives me 2. So maybe the number machine is adding 1 each time. Put a 1 in, plus 1, out pops a 2. That works. Let's see if it works for the next row. Okay, put a 2 in, number machine, add 1, out pops a 2 plus 1 is 3, not a 4. So that actually doesn't work. It has to work for all the rows, right? It wouldn't work for this one either. 3 plus 1 is not 6. So I know it's not going to be plus 1. So that actually doesn't work. Well, let's try times then. What could I multiply 1 by to get 2? Well, that's 1 times 2 equals 2. All right, let's see if maybe the number machine is multiplying by 2 each time. All right, 2. If I put a 2 in, the number machine multiplies times 2. Does that give me 4? Yes, it does. How about the 3? Put a 3 in, the number machine multiplies times 2. 3 times 2 is 6. That works as well. Let's try this next one. Put a 4 in to the number machine, out pops a 2. The number machine multiplies by 2, out pops an 8. That does match. So the rule that this input-output table is following, every single time it is multiplying times 2. So it's kind of like a puzzle we have to figure out. And you always look between the input and the output. You don't look up and down the rows like this. All right, let's try another one. All right, here's another one. Sometimes instead of saying input output, it will use the words position and value, but it's the same thing. So this is the input, this is the output. All right, same thing. Sometimes you'll see the words position and value instead. So you can kind of imagine our little number machine here. We're going to put numbers in, we're going to get numbers out. We have to find what is that number machine doing. All right, so if I put a 1 in, out pops a 4. How can I get from 1 to 4? Again, they're getting larger, so I know it's either adding or multiplying. Let's check adding, because that seems a little easier. All right, 1 plus what gives us the 4? 1 plus 3 gives us 4. So let's see if that works. Remember, it has to work for everything. All right, well, what about 2 plus 3? If I put a 2 into this box and the number machine adds 3, yeah, that would work. Out pops a 5. If I put a 3 into the number machine and it adds 3, out pops a 6. 4 plus 3 does give me 7. 5 plus 3 does give me 8. So that one, our number machine, the rule that it was doing each time is it was adding by 3. All right, let's check this one. Sometimes you'll see them written instead of up and down like this, input, output. You'll see them written sideways like this, but inputs on the top, outputs here at the bottom. So again, you are still always looking between the input and the output sections. So you have to compare. Sorry, I had to pause it real quick. Someone came in the room. Let's keep going. Sorry. So input output tables, they can be written sideways like this. So remember, you still look for what number goes in and what number comes out. So if here's my number machine, what number's going in is a 12. What number's coming out is a 5. So this time, my number machine is making my numbers smaller. So remember, if my number is getting smaller, there's two things that can be happening. My number machine can either be subtracting something or it can be dividing by something. Let's see, what could my number machine be doing if I put in a 12 and out pops a 5? Think about it for a second. So if I put in a 12 and out pops a 5, what could my number machine possibly be doing? Well, it could be subtracting by something. Could it be dividing by something? Does 12 divide into 5 equally? It doesn't, so it's probably not going to be division, but it can subtract. So 12 minus what gives us 5? 12 minus 7 gives us 5. So let's check that for each one. Okay, what if I put a 13 in? 13 minus 7, does that equal 6? Check it out. So 13, 12, 11, 10, 9, 8, 7, 6. Yes, it does. How about 14? If I put a 14 in, my number machine minus 7, minus is 7. Does that equal 7? Yeah, 14 minus 7 is 7. 15 minus 7, yes, is 8. So in this case, we go from top to bottom, from input to output still. This rule is minusing 7 each time. All right, let's look at one last one, because we've looked at a multiplication example, an addition example, a subtraction example. You can guess what this one will be. All right, here's our input-output table. Remember, this could possibly be called position and value. So if my number machine, I put a 25 into my number machine and then out pops a 5. Put in a 25, out pops a 5. My number machine is making my numbers smaller. So again, that could be either division or subtraction. Let's check subtraction. So 25 minus what gives me 5? Well, that would be minus 20. Does that work for all of them though? So what's 30 minus 20? 30 minus 20 is 10. Is that what they say pops out? No, they say 6 has to pop out. So minus 20 is not going to work. I know it's going to have to be a division problem then. So what can my number machine divide by for this to work? So what is 25 divided by what gives us 5? 25 divided by 5 equals 5. So if I do 25 divided by 5, that equals 5. Let's see if it works for the rest of them. 30 divided by 5, yeah, that equals 6. 35 divided by 5. Yep, that equals 7. 40 divided by 5. Yep, that equals 8. So this rule is it was dividing by 5 each time. All right, so that's real quick how to read and find the rules for different input-output tables. Now let's quickly look at one example here. So here's an example. We're going to see if we can find the rule that goes with this input-output table. So it says the table shows the relationship between the position of a number in a pattern and its value. Remember, it will still say position and value. This is input, output. Which rule shows how to find the value when given the position? So we're looking for the rule. If I put in a 1 and out pops a 33, what is happening? If I put in a 2, out pops a 34, should be the same rule. Put in a 3, out pop a 35. Put in a 4, out pops a 36. What is the rule that's happening between each of these every time? Remember, it has to be the same for each pairing. So is it multiplying by 3? Well, 33. Let's check A. 1 times 33 is 33. That works. 2 times 33, that's 66. That doesn't work. Okay, so I know it's not going to be A. Let's check B. Minus 32. Already, look, I know my numbers are getting larger, so I should know it can only be addition or multiplication because my numbers, look, they're getting bigger. And if I subtract or divide, I know my numbers will be getting smaller. So I don't even have to check B and C because I know that they are unreasonable because I know my numbers have to get bigger and these would both make my numbers smaller. So I'm not even going to check them. So let's check and make sure that D works. So D is saying plus 32. All right, well, if I put in a 1, I plus 32, does that equal 33? Yes. How about 2 plus 32? That does equal 34. 3 plus 32, yes, that equals 35. 4 plus 32, yes, that equals 36. So the rule for this input-output table would be D, it's a plus 32 pattern. Okay, you guys are going to try some of these on your own. Good luck. Let me or Mr. Johnson know if you have any questions.